We've always been fascinated by genius. But have you ever stopped to think, from an evolutionary point of view, why is it so incredibly rare? Well, today we're going to dig into a really cool hypothesis that connects genius to things like ADHD and even addiction to uncover the hidden biological price of being brilliant.
And that right there is the big question. Think about it. In natural selection, traits that help us survive and thrive are supposed to spread. So if being a genius gives you such a massive advantage, you'd think we'd all be geniuses by now, right? The fact that it's so rare tells us there's got to be a catch, a pretty significant downside that we need to figure out.
Well, the leading theory is that the genetics behind genius aren't just some simple upgrade. It's more of an evolutionary gamble, a real high-risk, high-reward strategy. Sure, the payoff could be groundbreaking creativity, something amazing, but the risk of things going wrong is also huge. And it's probably that built-in risk that's kept this trait from ever becoming the norm.
Okay, so to really get this trade-off, we've got to look at our genes. And the investigation points to one prime suspect, a very specific genetic variation that messes with the brain's whole reward system.
Meet the DRD4/7R allele. Now, the technical name is a mouthful, but let's just break it down. Dopamine is basically the brain's go-get-it chemical. It's what motivates us, and our receptors are like baseball gloves, catching that dopamine. The 7R version of this gene basically creates a less sensitive glove. That means you need a lot more dopamine thrown at you just to feel that same sense of reward or satisfaction.
So what happens when your dopamine receptors are kind of sluggish? Well, your brain starts craving more stimulation to make up for it. This creates this really powerful, deep-seated drive for anything new, for exploration, for more intense experiences. It's a mind that is just constantly searching, just to feel a normal level of engagement.
And this is where the story gets really interesting. Because when we connect this one gene to the real world, you see, scientists started to notice something strange. A whole trail of clues from totally different fields that all seem to point back to this exact same biological mechanism. They found 4 clues that, on the surface, look like they have nothing to do with each other. First, there's a statistical link between this gene and having ADHD. Second, people with ADHD often show what's called hypercuriosity, just this restless, intense drive to explore. Third, this same group, unfortunately, has a higher risk for addiction. And finally, that same intense curiosity is a hallmark of highly creative people. It's a weird mix, right? But they all share that same genetic thread.
So this brings us right to the heart of the mystery. How in the world can one little gene be tied to something we admire so much, like genius, and also to things we often see as disorders, like ADHD and addiction? It just feels like a complete paradox. But the answer, it turns out, isn't in the behaviors themselves, but in the underlying brain wiring they all share.
The key to solving this puzzle is in the brain's wiring, because, neurologically speaking, the urge to discover some new law of physics and the craving for a drug, they're not as different as you might think. They're actually running on the same ancient operating system in our heads.
What neuroscientists have figured out is pretty mind-blowing. The brain's reward pathway, which is powered by dopamine, doesn't really care what the reward is. The satisfaction you get from solving a tough problem and the rush you get from a risky bet, they literally light up the very same neural circuits.
Yeah, you can think of dopamine as the brain's universal currency for motivation. It doesn't care if you're chasing after food or money or the answer to some huge cosmic question, the chemical payment is exactly the same. And this means that a system that's built for seeking novelty can be channeled into incredible intellectual discovery, or it can be hijacked by something destructive. Okay, so let's put all these pieces together. We've got the evolutionary logic, the specific gene, all those behavioral clues, and the shared brain circuits. We can now build a single, really coherent scientific hypothesis that explains the whole picture.
And the hypothesis is actually pretty simple. First, this gene variant gives a person a really powerful innate drive to explore. But second, and this is the key, this drive is a total double-edged sword. Whether it leads to amazing things or to dysfunction isn't decided by the gene itself. It's all about a mix of other things, like your environment, your upbringing, your education.
And this is the absolute crucial point. On one side of the sword, that relentless drive can fuel incredible creativity and a deep search for knowledge. But on the other side, that exact same drive can show up as distractibility, impulsivity, and a really high risk for addiction. It's one drive with 2 completely different potential futures.
Now, it's super important to be clear about what this hypothesis is not saying.
This is not a genius gene. It's more like a restless curiosity gene. And just having it doesn't guarantee anything at all. It just opens up possibilities for better or worse. And finally, curiosity itself isn't inherently good or bad. Its value all comes down to where you point it.
So, this brings us all the way back around to our original question. Why is genius so rare? Well, this hypothesis gives us a powerful and honestly a kind of sobering answer about what exceptional talent really is.
And here's the fundamental takeaway. Genius is rare because the very biological engine that powers it, that relentless, novelty-seeking drive, is inherently unstable. The same genetic wiring that creates the potential for incredible breakthroughs also creates a deep vulnerability to distraction and addiction. Evolution just couldn't make this trait common because the price for all that potential is a constant and very significant risk.
So this leaves us with a really provocative thought. If the potential for genius and the risk for dysfunction really do come from the exact same biological place, how should that change the way we think about things like education and mental health? It suggests that maybe managing the risks that come with this kind of mind is just as crucial as nurturing the talent. Something to think about. Thanks for tuning in.